Hello everyone. In this video, I will be discussing on the programming model of your 8085 microprocessor, how the programming is being done in 8085 microprocessor, how it flows over here in 8001. So this lecture helps the students to gain knowledge in 8085 microprocessor programming model will be knowing. So what actually microprocessor, how the instructions should be held, moving on, and this would be helping you in writing the timing diagrams. So I meant to say drawing the timing diagrams of your 8085 microprocessor, how the instruction. So microprocessor executes instructions given by the user. These instructions should be known to the microprocessor. So these instructions are being decoded, I mean to say, but the microprocessor understands only the machine language, which is composed of zeros and ones or hexadecimal digits, whatever it is. So these how it is work. For example, this is one number 01001111. This is one valid machine code of an instruction of your 8085. What it does, it copies the contents of internal registers, one register to the another register. But once we see this code, we can't understand. This we see that these are just in a series of ones and zeros. So here, once you give this one, copy value 2h in 2 hexadecimal value into what? A register. Copy 4 hexadecimal value into the B register. These are the two opcodes, which is nothing but this is one opcode, we say. This one operand. This one operand, which is represented as 2. Here, this value is represented as 4. This is what an operand. So, coming to over here, this is what? This is your operand, and this is operand. Value over here is shown over here as what? This is the value which would be shown over here as 4. And the next one, assembly language program. So this would be understood by our English words to convey the action taken as a mnemonics. We will be defining in the form of mnemonics. So for example, MOV is to indicate a data transfer. Add is there adding two values. SUB is there subtracting two values. This is one of the simple program for addition of two numbers. MVI A, 2H, MVI B, 4H. So what this instruction does is that it will copy the two value into the A register. Similarly, this is an immediate value 04 which is given in the instruction. It has been copied into the B register. The third instruction is add B. So as far as this instruction is considered, it will add the values of A with the B and the result is stored in your A register. This is confined fixed one, and this would be the flow in every 8085 microprocessor instructions. So how this will be carried out, this would be the same. So the assembly language is understood by us, machine language is understood by the microprocessor. So the conversion, how we convey the information in the form of mnemonics. Assembly language is a specific given to a microprocessor. It's different than any other microprocessor. For every microprocessor, it would be different. This assembly language program structure would be the same, but how you use it would be different. So the microprocessor understands machine language only. Remember, every time it understands only the machine language. So microprocessor can't understand a program written in assembly language. So what it does, it takes the help of an assembler. A program known as assembler is used to convert a machine language program, assembly language program to machine language. This is the part of an assembler which does this process. Then they will be generating a machine language code with it. So this code, so machine language and assembly language both are microprocessor specific machine independent. So they are called as low level language. Machine independent languages are high level languages. For example, the C++, Java, etc. All these are understood by the machine itself. Again, you should not have that. So this is the programming model of your 8085 microprocessor. So in your 8085 microprocessor, you would be having some accumulators would be there, ALU would be there, And there are 5 flags, as you already know, to that one. It is one of the most important part, which is nothing but an instruction. So one will be going on fetching up the data from the memory location using first we'll be locating the memory location using a 16-bit address bus and reading out the data through the memory into the microprocessor and passing on some control information. And then sometimes we'll be going for sending at the memory address and then read. Once we have performed the reading operation, the other time we will perform the write operation. Every time we perform the read operation, every time we can perform the write operation. It depends on to that one. So the programming model, I meant to say, when you are defining a program, it should be very much confined that whether you are taking a values from the memory location, how we are restoring back those values into the registers, make use of the specification registers, and how to provide the pointers. These are the most important things when you are designing a program. So the memory pointers should be located perfectly, we define the pointers perfectly, and the register array, how efficiently you are using the register array, that also takes place in a very crucial role in designing the programs. So when you are designing the programs, most important thing is that specify the memory address from where you are collecting the data. Then once you have received the data, how you can utilize these data values into the program. Let's take addition of numbers. As we have seen in the previous example, addition of 2 numbers. Right now, we are taking directly the numbers over here. More or less, when you are having a program of addition, so be careful that one of the numbers should be in A register. Be careful not it is the number one of the number in A register, the number in any other register. Then adding up the two things, you will be having the result in A. So this basic knowledge you need to have it up where the input numbers are stored, where the output numbers are stored, and how you need to specify the memory location. All those things will be helping you in designing the very good efficient programs. So overall here, this is what a programming model consists of an register array, memory pointer registers, and accumulator. This is very important one which should be helping you in designing the programs. And ALU does the execution process. It does the execution. According to the execution, it sets or resets the flags, and whatever the next instruction is there, according to that one, it will be decoding it up, and the instruction decoder will be being overall here these are synchronized with the timing network. So thank you everyone for watching this video. I hope you have understood how a programming model of 8086 migrate 8085 process. Thank you everyone for